Hi, today we're going to start our unit on trigonometry. And what you learned in the past about sine, cosine, and tangent, that was just a small part of a bigger picture. Today you're going to learn about the foundations of trigonometry, what it all means, and where it came from. You learned about the three, sine, cosine, and tangent, like I said, but there are in fact 6 trigonomic functions. So we're going to start with question 1 and just review our first 3 again, and then we'll learn our new 3 functions. So question 1 says, in triangle ABC, angle B is a 90-degree angle, telling us it's a right triangle. A to B is 12. Let me get my highlighters. So A to B is 12. B to C is 5. And then A to C is 13. All right, we have to find each of the following. So going back to our 3 basics, sine, cosine, and tangent. Sine is the ratio of the opposite side over the hypotenuse side. All right, so looking at our picture, the opposite side, well, let's label our sides. We're dealing with angle A, so here's angle A. And first labeling, we want that side to be opposite. Across from the 90 is your hypotenuse. And then by default, this side is the adjacent, the side next to the angle. So the sine is the opposite divided by the hypotenuse. So the opposite side is 5. And the hypotenuse side is 13. So sine is 5 over 13. All right, now it says just what is the sine value. So all they want is the ratio. If they wanted you to find the angle, they would have said what is the measure of angle A. So by saying sine A, they just want the ratio that represents sine, not the actual angle itself. So cosine. Cosine is equal to the adjacent side over the hypotenuse side. So the adjacent side in our problem is 12. And the hypotenuse is 13. And then lastly, tangent. Tangent is equal to the opposite side over the adjacent side. So in our problem, the opposite side was 5, and the adjacent side is 12. Okay, so our 3 new functions, what are those letters, CSC? That stands for cosecant. And cosecant is the ratio hypotenuse over opposite. So if you notice, they're just reciprocals. They're flipped. So these guys on the right-hand side are the reciprocal functions. So if sine is 5 over 13, we know cosecant is 13 over 5. Because it's H over O. SEC, that's pronounced secant. And secant is just cosine flipped. They're reciprocals. So it's H over A. So if cosine is 12 over 13, secant would be 13 over 12. Lastly, this word cot that people want to say cot is actually really cotangent. And cotangent is A over O. It's tangent flipped, the reciprocal. So in our problem, if tangent is 5 over 12, cotangent is 12 over 5. Okay, in example 2, in right triangle ABC, shown below, A to B is 18.3. and B to C is 11.2. What is the measure of angle C? All right, well, angle C is what we're trying to find. But this one says that we have to find angle A to the nearest minute. Now, that might seem like it's hard. I will first do a little sidebar question just so you can understand what we're talking about. Let's pretend, for example, that we get an answer of 42.5 degrees. So what would that be to the nearest minute? 42 would be 42 degrees still. But this part right here is where the minutes come in. Minutes and seconds, just like a clock. There are 60 minutes in an hour, so there are 60 minutes to a degree. And then again, seconds, 60 seconds to the nearest minute. So 0.5 would be half of a clock, right? And that would be half of an hour, which would be 30 minutes. So this is just an example. 42.5 degrees would be the same as saying 42 degrees, 30 minutes. So on our problem, if we want to find the angle to nearest minute, we are going to first find the angle like we normally do and find it in degrees, and then we would convert to minutes after. Okay? Find angle like normal. Then convert. Okay, so to find the angle like normal, we have to label our sides. So the 18.3 is our opposite side. The hypotenuse is the one without a value. And then the adjacent is 11.2. The two most important sides are the opposite and adjacent sides. So opposite and adjacent go with tangent. So we're going to start by setting that up. I'm going to start with the formula. So that's the formula we're going to use. Now we're going to fill in our information. Tangent, the angle is, we don't know, x. The opposite is 18.3 over the adjacent 11.2. So in order to actually figure out the angle, because they actually want the real angle, we are going to then bring tan over to the other side by doing tan inverse. Okay, putting that in our calculator. Oops. Tan inverse, second tan of all right, and we get that answer. Now that answer is our degree value. So if we have to round it to the nearest minute, we know that our answer is definitely going to be 58 degrees. This part right here is what makes the nearest, or the minute marker. So we already talked about how a half a degree would be roughly half of an hour, which is 30 minutes. So we can estimate that that's going to be just over 30 minutes, maybe 31, 32, 33 maybe at the most. But we don't have to figure that out. The calculator can actually do the conversion. On the 84, you're going to do second, apps for the angle menu, and number 4 is the degrees, minute, second conversion. On the Inspire, you hit, there might be a quicker way, but you hit the book button, and then you under tab 1 where you have the alphabetical listing of everything, press D for the D section and scroll to find DMS. Okay, so after you do that, you get that value. So what does that mean? Well, there's 58 degrees. This guy with that little marker, that's the minutes symbol. But then you also have to look at the following part, because just like you round, if you want to round to nearest minute, you always have to look on the other side and see if it rounds up or stays the same. This is the seconds. So just like a clock, 56 seconds, is that going to be closer to the next minute? It definitely will be. Just like a clock, you go up to 60 seconds to reach your next minute. So 30 seconds or more, you round up. So our final answer then will be 58 degrees, and it will round to 32 minutes. Okay, now we're going to start, where do these values come from? Where does trig come from? All right, the next page is the foundations of where trig comes from. So we're going to do a couple of notes, and then we're going to flip back and forth with our problems. So what happens is that trigonometry comes from using a unit circle. And a unit circle means a circle that has a radius of 1. So here's my radius. That radius is 1. All right, and what happens is we are going to rotate angles around the circle, and that's the angles we're referred to in our triangle. So when I say it's a 30-degree angle, I'm talking about that rotation of that particular angle on that circle. The most important things is, where do I draw the circles or the angles? Because if I ask you to draw a 90-degree angle, there are a lot of 90-degree angles I can draw in that circle. But we have something called standard position. Standard position is where the initial beginning angle starts, the initial side is what it's called, starts on the x-axis. And then from there, the angle is going to rotate, and it's going to either rotate up, positive angles, they're going to rotate up, if the angles are like positive 30, and the angles are going to rotate down if it's a negative angle. Where the angle stops is called the terminal side. So the terminal side is actually that yellow piece I already have written in. Terminal means terminate. So angle rotation, standard position, you start there. Up is positive angles, rotate down is negative angles. So let's start with that piece of information first. We're going to do problems 1 and 2. Problem 1, on the unit circle shown below, and you'll hear that phrase a lot. That just means that we're talking about the basics of trig. They start on a unit circle. Sketch an angle in standard position whose degree measure is 200. So you have to know that standard position means that you start here. That's standard position. You start there. And then you're going to rotate to find 200. Now that's why they said sketch. They don't expect you to be perfect, but as long as you're in the ballpark. So as we're rotating, positive means to go up. So as we're rotating, up to here, that would be 90 degrees. Down to here, that would be 180. And so 200 will be roughly a little bit past that, 20 degrees past that. So there's where my angle will terminate. That's called the terminal side. This is not good enough because I also have to show which way the angle is rotating to make 200. So then you would show this, and that would be your 2 points. So we'll try this one more time. Example 2, on the unit circle shown in the diagram below, sketch an angle in standard position whose angle is negative 75 degrees. So again, sketch, standard position. So standard position means we start here. Negative 75 degrees means we're going to rotate down. And this would be considered negative 90. So negative 75 would be right around there. And then we're going to draw our angle to show that it's rotating that way. And that would be negative 75. Okay, going back to our notes. Now there's something called coterminal angles. Coterminal angles mean that they are the same angles because they both land or end at the same spot. So, for example, because you can't see me, I'll just do this. If I rotate 200 degrees this way, what other measurement, so that's 200, what other angles will also land there? Well, think about it. I can start here, but this time go around this way, and then I could also land on that, and that would be negative 160. Not only can I do that, I could swing to 200, but then swing around one more time, and that's another circle all the way around. So 560 would also land in that same spot. I could keep on circling around all day long. So when you're talking about coterminal angles, think about if you are facing a certain direction, you could do a complete 360 and still land or be at that same position. So think circles. So think plus 360 or minusing 360. Now, you can keep on swinging around all day. So there actually are infinitely many coterminal angles, but we're going to just stay right around a circle or just a circle above that. All right, so now we're going to go back to our problems and try doing these type of angles, coterminal. So problem 5, which angle is coterminal with an angle of 125? Now, you can do this in one of two ways. You can either A, sketch a picture for all 4 choices and see which ones land in the same spot, or we can do the circle method. I'm going to do it both ways so that you can have an idea. So because we have choices, the visual way will also work. 125 is a up angle because it's positive. So 125 will roughly land around there. That's 125. Okay, what other angle will also land there? Well, choice number 1 is a negative angle. So negative 125 would land somewhere like that. So those don't land in the same spot. It's not choice 1. 425 is a positive angle. It's a complete circle at 360. And then another 65 degrees for 425. So that's what 425 would look like. This means a circle and a little bit more. And those don't land in the same spot. Negative 235, choice 3. Well, that's negative 90, negative 180, and negative 235 would land right there. And we could actually figure out the gap and make sure this is correct, but just to be safe, 235 is forward. So that's 180, and 235 will land somewhere here. So definitely the one that matches the angle is this one. Those two are coterminal. They land in the same spot. The other way you could have done this problem was you could have done it by the circle method. You can think circles. 125, you can either add a full circle forward, or 125, you can subtract a full circle back, and you will be in the same spot. So if I add a circle, I'm at 485. That is another coterminal angle. If I subtract 360, I get negative 235. And that's another coterminal angle. And that's the one that's listed. But there are many more. You just want to go with the one choice that's right. So we'll try this one last time. Example 6, state 2 angles, one positive and one negative, that are coterminal with negative 140. Again, we can draw our picture. So basically negative 140. That's negative 90. That's negative 180. So negative 140 would be about 50 degrees past that. So right there, that's negative 140. So what other angles land there? Well, if I think circles again, I can either add a full circle forward, or I can subtract a full circle back. And the coterminal angles are, let's see, positive 220 or negative 500. all of those angles will all land in the same spot. Okay, so now that we understand how angles are rotating and that angles can swing around and land in the same spot as other angles, now we can talk about where the trig values come from. So going back to our notes, as angles are spinning around the circle, now remember this is a unit circle, so this is radius is 1. So as angles are spinning around the circle, they're going to hit the unit circle. Now let's pretend for a moment that this guy right here is a 60-degree angle. This side of the angle is going to hit that unit circle, and it's going to produce a coordinate, a point of intersection. Where the angle hits the unit circle, those coordinates, that's actually where trigonometry comes from. The x coordinate is the value of the cosine of that angle. So the cosine of 60 degrees would be the x coordinate, and the sine of 60 degrees for our particular problem, I should write 60, would be our y coordinate. All right, so that is a really important fact. X is the cosine value of the angle, and y is the sine value of the angle. So I have a song I got from somebody to help you remember. So x is cosine, y is sine, on the unit circle, all the time. So hopefully that will help stick in your brain which one goes with what. So just a little interactive site to show you. Okay, so saying our 60. So there's my angle. My angle is rotating. My angle, that 60 degrees from right here, rotates and hits that spot. The x value is actually the value of cosine of 60, and that's where the 0.5 comes from. So this would actually be 0.5, comma, and then the sine value is what the y coordinate is. So 0.866. It's actually irrational number and goes on forever. They just rounded it here. So that's where these magical trig values come from. If you notice, the 60-degree marker goes up, and then there's a red line down and a blue line over. That is forming a right triangle. So this piece right here, that's the x value over, that equals cosine. And the red piece up, that's the y value. That equals sine. Now, I'm going to write these for a second so I can illustrate what happens when you go past a normal triangle in the first quadrant. So here is sine of 60. Here is cosine of 60. Let me write them. And I'm just copying. Again, this is all stuff I just want you to listen to. Okay, so I'm now going to take these off. So if I rotate my circle to 120, notice what's happening. This is another triangle. Here's my ray. My angle is here. My angle rotates to here, but the triangle is always formed by drawing it back down to the x-axis. That's key. And same as before, the x is the cosine value, and the y is the sine value. So if you notice, the sine values are identical. And why is that? And the cosine values are almost identical. 60 was 0.5. This is negative 0.5. Okay, so just a sign change. And tangent, same thing happened. This was 1.73, and that's a negative 1.73. Okay, why they're the same values is because this is actually the same triangle. If I redraw the other triangle in, 60 was right here. All these are is a mirror image of each other over the y-axis. So the values stay the same. The only things that change are the signs. And this should make sense. On this side, x's were positive, so x cosine was positive. But on this side, you're going in the negative direction. X is negative, therefore cosine is negative. Because these are both up and up, those both have the same sine value, and they're both positive. Now, this triangle can be flipped in all the quadrants. So again, I am going to keep the same 60-degree triangle, and I am now going to move to 240. Sorry. And again, notice that the angles are the same because this triangle right here, and this triangle are exactly the same. The 60 degrees, I know that's bigger than 60 degrees. We said it's 240. The 60 degrees comes from right here. The angle we're referring to is always the pocket angle. So over here, it was right there. That's 60. So it's the same triangle, and over here, it would be 300. The only thing that changes is the positives and the negatives. So now I'm going to go back to our notes and explain what all this means. So not only do we know that the x is the cosine value, sine is the y value, it's obviously then going to affect our positives and negatives in our quadrants. Remember, I told you the triangle are the same triangle in all of these quadrants. The only thing that changes are the positives and the negatives. So this is what this all means. In this quadrant, the first quadrant, 1, all of the trig functions are positive. So they're all positive. In quadrant 2, only sine and its buddy, remember cosecant is sine flipped, so anything that happens to sine also happens to cosecant. Sine is the only guy that's positive, and all the other guys are negative. In the third quadrant, tangent and its buddy cotangent are the only ones that are positive. Everything else is negative. And then in the fourth quadrant, cosine is the only guy and its buddy secant are positive. Everything else is negative. All right, so we're going to put all of this together now. We're going to put together x is cosine, y is sine, and then talk about why it's important to know which ones are positives and negative and how that affects where we are at. So we're going to go now and do examples 7, 8, and 9, and 10. Okay, in problem 7, they tell you that you are working with a unit circle, and again, they'll always come up a lot so that you realize that we're talking with our basic trig. Unit circle. All right, so here's our unit circle. It means that this guy, this radius is 1 from here to here. Then they tell you that these guys are perpendicular and these guys are perpendicular, just to make sure you realize there is a 90-degree angle there, which they do demonstrate in the diagram. And they want to know which line segment represents cosine theta. Well, on a unit circle, we just did the song, x is cosine, x is cosine. So the x segment equals cosine. Okay, well, here's x, and x goes left and right, but then we have that or that. So this, something to do with those letters are going to be the x segment. So it's definitely not going to involve t or p. T and p are gone. So which one is it? Well, we talked about how it has to be on the unit circle. So when you draw your triangle, you go up and hit the unit circle, and then you come back down. So we're really talking about this green triangle. Out of that triangle, the x value, the x direction, is cosine. So cosine is x, and not that we have to, but the y value would be sine. So the answer is cosine is equal to the OR segment. if you really were, they could have also turned the question around and asked you for the sine. So if you want to write this in your notes, y is equal to sine, and that would be the PR piece. You can also give yourself a little, thing. Sine goes up and down, and cosine goes left and right on the triangles that are on the unit circle. Okay, next question. Putting this all together, remember how angles rotate, your positives and your negatives. So we have, again, that we have a circle that's on, or have a circle that is a unit circle. So again, that's important, because if I know this is a unit circle, I know that there's something special about the values of the coordinates where it's hitting. X is the cosine value, and y is the sine value. Now notice that cosine is positive and sine is negative. And I showed you on that interactive that as you're going around, the values are going to change from positive to negative because x is cosine, so x is positive. And then y is the sine value, and y is negative, and that's where those are coming from. So I'm going to write down my two facts that I know. I know that this is cosine. I know that this is sine. All right, so what are we asked? We are asked to find what is the measure of angle theta. This symbol here, I apologize, it was over here. That symbol theta is your common use of a variable to represent the angle. So theta in trig is like x in algebra. All right, let me write down my two most important facts. Cosine of the angle is equal to a half. I know that because I can read the point and know what the point means. I also have that the sine of the same angle, because it's still the same angle, is equal to negative radical 3/2. My question is, what's the angle? And it didn't show up in the picture, I apologize. The angle we're looking for is the angle it takes to swing to get there. We most always talk about the positive angle. We don't normally ask you to find the negative angle. All right, so we have actually more information than we need, because in order to find an angle, I just need to know one value. And since this guy right here is easier to work with than that radical number, I am not going to work with that one. I'll just work with the cosine one. You can pick and choose which one you want, because you guys already reviewed that if you want to find an angle, you're going to bring cosine over to the other side by doing cosine inverse. All right, so putting that in our calculator, we get 60 degrees. Now, wait a minute. It's not definitely 60. We know that this is swinging to be 90, and this swings to be 180, and this swings to be 270. So we know that our angle has to be somewhere past 270 up to 360. 60 is actually really important. It's not that it's the actual answer. Remember that when we do trig, we're always working with the right triangle. So that 60 is actually the main angle that's right here in the pocket of the triangle. And we're always going to work with the x-axis, and we're always going to work with the angle that's closest to the x-axis. So that's what the 60 represents in the picture. So if we have, and let me clear everything out, if we have that this angle right here is a 60-degree angle, and I want to find this angle, what is it? Well, that, in that case, that makes a complete circle. So that is going to be a 60 or 300-degree angle. So 60 is the what's called the reference angle, because we're referring to that triangle and that angle, but the real angle is really what it takes to swing all the way around. So the real answer then is 300 degrees. Now, when you're doing these swinging angles, let me just throw in an extra page for a second. These are the three things that can happen, or the four things that can happen. And again, you don't have to do this in your notes, just want to do a little extra. Your angle's either going to swing here, swing there, swing there, or swing there. Just use the axes as guidelines. If your angle, if you do cosine inverse and you get 60 there, then the actual angle itself is 60 degrees. So that one's easy. If when you do your cosine inverse and you have your triangle in the second quadrant, you get that angle. But we really want to know this angle. Well, again, just look at it as from a geometry perspective. This is 180. You're not quite there. You are 60 degrees off of 180. So this would be 180 minus 60, which is 120. In this quadrant, right here, here's your triangle. Let's say you do cosine inverse and get 60 again. And that would be where the angle is located. It's always located right at the origin between the x-axis and the angle. Now, we really want to know what the angle is to take to swing there. So we're really looking for all of that entire angle. Well, this is 180. You are more than 180. You're, in fact, 60 degrees more than 180. So the real angle then would be 180 and 60 more. And we just did this one, but when you do this in quadrant 4, your angle, when you do cosine inverse, if it lands there, the real angle is all the way around. And for this one, a lot of kids want to use like 270. We never ever use the y-axis. It's always the x. So this is 360, and you're not quite at 360. You're 60 degrees away from it. All right, so that's just how you would figure out what angle you're really at. After you do cosine inverse, you're finding the triangle's angle. To find the real angle, it depends on what quadrant you're at. All right, so 4 more examples. Example 9 and 10 have to do with the positives and the negatives. So I told you as we were going around the circle that your signs are going to change, but the values themselves are going to be the same except for the positives and the negatives. And that's just dependent upon which quadrant you're in. So in order to figure out what quadrant you're in, you just have to figure out the clues they give you in the problem. So example 9 says cosine theta is greater than 0. Well, that's telling you that cosine is positive. Okay, then they tell you later on that sine of theta is less than 0. And I'll highlight it. So cosine theta is bigger than 0 means this. And sine theta is less than 0 is going to mean this. So based on that, we can figure out where we're at. In the chart, I gave you this on your main note page. They're all positive there. And then as you go around the quadrants, in the second quadrant, it's A, S, T, C. They're all positive. If they're not all positive, only one of the 3 major functions is positive. Sine only is positive in quadrant 2, tangent only is positive in quadrant 3, and cosine only is in quadrant 4. Now there's several ways to do this. Some people do the check mark system. I like to just do the positive system. If they're not all positive, see this guy right here, he's negative, that means we cannot possibly be in quadrant 1 because they would all be positive. So which quadrant are we in? Well, positive is the winner. Whichever one of the 3 is the positive guy is the winning guy. And I can see that this guy is our positive winner. And cosine goes here, so we're in quadrant 4. Now, by default, once you know 2 of them, you know all 3. Because they're either all positive, which they're not, or only one is positive and the other 2 are negative. So I actually know tangent is negative, even though they didn't tell me that. Okay, we'll try this one last time. I want to know what quadrant we're in. And they tell you that cotangent is less than 0. Now, if cotangent is less than 0, we really want to work with the main function. So cotangent is going to go with tangent. And then we have secant. Again, we want to use our main function. We'll switch it. Secant is less than 0. So what does that all mean? Cotangent goes with tangent. So when they tell me that cotangent is less than 0, they're really telling me tangent is negative. And when they tell me that secant is less than 0, secant really goes with cosine. So they're telling me cosine is negative. And again, I know they didn't tell you this, but you know by default then, if tan is negative, cosine is negative, you know they're either all positive or only one is positive. Well, it must be that the third guy's got to be the positive one. All right, so which quadrant are we in? A, S, T, C. Once we have tangent and cosine are negative, we know we're not in quadrant 1 because they have to all be positive. So the winner is the positive one. Sine, sine. We're in quadrant 2. Okay, lastly, putting this all together. So this is going to actually require you to know a lot about trig, where everything is and what everything means. In a problem 11, they're telling you that the cosine of the angle is negative 12/13. They also tell you that cosecant is less than 0. You have to find the other 5 values. So basically, they gave you cosine is negative 12/13, and they want you to find all the other ones. So sine theta, they want you to find tangent theta. They want you to find, well, sine goes with cosecant, so they want you to find cosecant. They want you to find cotangent. Oh, I apologize, wrong spot. Cosine goes with secant. And they want you to find cotangent. All right, so you just have to think about what are all the things that you really need to know. Well, a couple of things I can do is I know cosine is negative 12/13, so technically I actually already have this answer. This is the flipped buddy. So he's got to be negative 13/12. Remember, reciprocals don't negate, you just flip. My question is, how in the world do I find the other ones? I know sine is O/H, but I don't have an O and H right now. So your first question is, draw a triangle, but most importantly, where is that triangle? So this is where questions 9 and 10 that we just did come into play. I have clues that tell me where my triangle is located, because not all triangles are going to be located there. That's not where all triangles are. So where is this triangle? Well, cosine is a negative 12/13. That means cosine is negative. And cosecant is also below 0. That means cosecant, which is sine, is also negative. By default, that means I know tangent has to be positive. So if I write my ASTC, I'm not in quadrant 1 because they're not all positive. Tangent is my winner. I'm in quadrant 3. So now I know where my triangle is located. You draw into quadrant 3 and you always go up to the x-axis. Theta is always located in by the origin, so that's my angle. And what else do I know? I know that the cosine value is negative 12/13. Now, cosine is A/H. So I know that the A side is going to be 12, and I know that the H side is going to be 13. Well, let's see. H is the hypotenuse. Hypotenuse is across from 90, so there's my H side. I know that that's 13. All right, my other two sides. This is opposite, which means this is adjacent. So I know that that side is going to be the 12 side, the adjacent side. I do not teach it by putting the negative on the 12. It technically is a negative 12, and you can get away with it as long as you remember to put the negatives on the appropriate functions. You're in quadrant 3. That means that tangent and cotangent are positive, and you know that all the other guys have to have a negative on it. So as long as you take care of the negatives in your answer, you don't have to put the negative on the 12. I think it gets in the way. I don't need to. All I know is that those 4 functions are going to be negative and the 2 bottom ones are going to be positive, and that's good enough. So how do I find the values? Well, basically, this is actually like problem 1. If you go back to, I'm going to go back to problem 1. You don't have to. But in problem 1, remember I asked you to find all the ratios, but all the numbers are given? This is the exact same problem. The only thing is you are missing the one side. And in order to figure out the missing side, you're going to do Pythagorean theorem. So we're going to put an x there, and we're going to use Pythagorean theorem. The hypotenuse has to be the c. The other two can be either answer. So then you would solve, subtract over, and take the square root, and you get 5. So once we have all three sides, it's just like problem 1. Sine is going to be negative because it's in quadrant 3, and the O side is 5, and the H side is 13. Then cosecant is just going to be that guy flipped. Tangent is O over A. The O side is 5. The A side is 12, and it's going to be positive in quadrant 3. And cotangent is going to be positive, but it's going to be flipped. All right, and lastly, example 12. Example 12 works actually the same way as example 11. Actually, I think it's easier because instead of you having to figure out which number in the fraction goes on which side, on this problem, you actually know. So if I draw my triangle or my quadrant, my point is at 5 over and 6 down. So there is my point. I draw my angle to the point, and then I draw my triangle up. Well, this is why I think this is easier. You now know that this side is 5 over, and you now know that this side is 6 down. But again, I'm just going to write positive 6. I have to now figure out how to get my third side. And there's my third side. We're going to use Pythagorean theorem. And you're going to leave it as a radical. I know it's ugly, but you have to. You can't round. It won't be the exact answer. So lastly now, we have to find our 6 trig values. Sine, cosine, and tangent. And sine goes with cosecant. Cosine goes with secant. And tangent goes with cotangent. Okay, I know that in the fourth quadrant, I know that's my C quadrant, A, S, T, C. So cosine is positive. All the other guys are negative. That's how I can get away with not putting the negatives on my answer. Now all I have to do is do my fractions. Sine is opposite over hypotenuse. Opposite is going to be the 6, and hypotenuse is going to be the radical 61, and that's the adjacent. So it's going to be 6 over radical 61. Cosine is going to be A over H, so 6 over radical 61. And tangent's going to be O over A, which is 6. I apologize. The A side is 5. It's going to be 6 over 5. And then the other guys are really easy. This is going to be radical 61. Radical 61 over 6 is going to be negative. Secant's going to be radical 61 over 5. And then cotangent's going to be negative 5 over 6. All right, and the last thing I have to tell you is that we don't normally keep this. You guys learned before that anytime a radical is in the denominator, we actually rationalize it. So just to show you what rationalizing looked like, our sine that was negative 6 over radical 61, we just multiply it by the radical, and that makes negative 6 radical 61 over 61, and that's called rationalizing it. You'll see that answer, then you would see the answer with the radical in the bottom.